Okay, so now we're going to talk about the last type of bond, which is a hydrogen bond. Okay, and if you need to remind yourself about the types of bonds, they're listed here. We've got ionic, covalent, both nonpolar and polar subtypes, and then the last type here is hydrogen. Okay, so I'd like to move to this image to discuss hydrogen bonds. Okay, so first, I actually let's move to this one here. So let's backtrack a minute to polar covalent, which we just discussed, but we're going to build on that. So let's just remind ourselves of what that is. Polar covalent is two atoms. They're sharing electrons, but they're sharing them unequally. And so that gives you partial charges. The electron hog is a little bit negative because it's holding those negative electrons tightly. And this guy's a little positive because it's not holding those negative electrons tightly. Okay, so now let's look at this image, and I want you to ignore the dotted red lines for right now. So don't even look at them. I want you to focus in on these two blue dots and this big red dot here. Okay, this right here is a polar covalent molecule. We've got two hydrogens and an oxygen. H2O, water. So this is water. And you notice there are these partial things here. So what that means is this hydrogen is a little bit positive, this hydrogen a little bit positive, this oxygen a little bit negative. So water is a polar covalent molecule. Okay, here's another polar covalent molecule. Now, what you should notice is that when you put a whole bunch of polar covalents together, those partial charges are going to be a little bit attracted to each other. So here you see the partial negative has lined up, and now look at this dotted red line, has lined up close to this partial positive. Here we go, partial negative lined up close to the partial positive. So all of the polar molecules are a little bit attracted to the nonpolar because of those partial charges. Now, notice they're not sharing electrons across this dotted red line. They're not stealing electrons across this dotted red line. All it is, polar molecules a little bit attracted. Now, because it's a partial charge, that means the attraction is not as great, and so they might be attracted for a minute and then move on, and then attracted for a minute and move on. Okay, it's a weak bond. It's a weak physical association. It makes these water molecules a little bit sticky. So you may have noticed that if you've ever seen a leaf of a flower and you notice the little dewdrop that kind of forms a little sphere on top of a leaf or a flower petal, that's because those water molecules, they're hydrogen bonding. They're a little bit sticky to each other. Okay. Now that's very different if you remind yourself of ionic bonds. Here we've fully either stolen or lost an electron. That makes us fully positive or fully negative. And so what this does is that means that this attraction is very strong because it's not partial charges, it's full charges. And so the analogy I often give to my students in class is that this is a strong bond. So this is like marriage. This is a legal contract. You're bound before the law. Okay? Whereas this here, it's a weak bond. It's a little bit of attraction. So it's kind of like dating. You're a little bit attracted and then you move on. Maybe. And a little bit attracted and then you move on. Okay, so weaker bond because of the partial charges. Okay, so let's go back to our chart here and let's finish filling it in. So is there a full or a partial charge on the atoms? We never filled this in for ionic bonds, so it is a full charge. Okay. Now let's go to hydrogen bonds and look through here. So remember that we said there's no sharing of electrons. There's no stealing of electrons popping from here over to here. So do atoms share electrons? No, not across that hydrogen bond. So this one doesn't apply. Do atoms steal electrons? No, there's no movement of electrons across that dotted red line. I'm going to have you just don't fill in this one. And then it asks here, are the bonds formed by the attraction of charges? Well, you bet. This partial positive is attracted to the partial negative. And so, yes. Okay. Now, let's talk for a minute. So what this is saying here is that this is a polar molecule, this is a polar molecule. They're attracted to the hydrogen bond with one another. So polar molecules, hydrogen bond with polar molecules. But what about nonpolar, where there's no charge? Well, polar molecules, turns out they repel nonpolar molecules. Some examples of nonpolar molecules are actually going to be fats and oils. Okay. All right, so the oxygen and hydrogen and water. So this, and this, not the dotted red line, but this, and this. That's polar covalent. So polar covalent. Which means that water, since it's forming a polar covalent bond, that makes it a polar molecule. Okay, so let's look for a minute and talk about hydrophobic and hydrophilic. Okay, so here we can split up these words. Hydro means water, phobic means fear, philic means loving. So literally, hydrophobic means water-fearing. And what that actually means is that anything that is hydrophobic repels water. It says, get away, I'm afraid of you, I don't like you. Okay. Hydrophilic literally means water-loving. And so that means that it is attracted to water. And you can fill that information in here. So now let's look at each one of these type of bonds and come back and fill in this part. Okay, so polar, we said that it's water, and fill in water, substitute water into this sentence if you need to. Polar is water. We know polar is going to hydrogen bond. It's attracted to water. So this one right here, hydrophilic. Okay. And what I'd like for you to do is look through your homework lesson or contact your instructor to see what makes sense. The principles to keep in mind is that water is polar, water is partially charged. So therefore, think about what likes charges, and that's going to help you fill this in. Okay, so let's look back at the lesson. I do want to show you one video here. This is showing you an actual demonstration, water, and then this here are little oil blobs, and you can actually see polar and nonpolar not mixing, live in action. You can do this experiment at home if you would like to. Okay, so this is water and oil mixed right here. polar and nonpolar repelling each other. Okay. All right. And I believe that covers that